Hey everyone, today I'm going to be talking about the battery design and operation and how battery works. As we know, the battery is the source of energy that supplies electricity to all the vehicle components such as the starting motor, headlights, taillights, and many others. So I'm going to be describing battery design, including battery plate and cell groups. Explain battery operation during the charging and discharging cycles, and explain two common battery ratings. So you must understand battery operation to comprehend how the battery operates in the charging circuit. For example, if the battery is gassing excessively, the charging voltage must be too high. You also need to understand that water is vented from the battery during the normal charging process. Therefore, only water, that is distilled water, should be added to the battery cells. So I'm gonna be explaining to you how the battery is designed and explain every parts of the battery. First off is the battery case. The battery case holds and protects the battery components and electrolyte. Electrolyte is like the battery solution that will be poured through the vent caps inside the battery case. Separating walls in the case form a separate reservoir for each cell. Battery cases have sediment spaces in the bottom of the case, which provides spaces for material shed off the plates. If this space were not provided, the material that is shed would make contact between the plates and short them together. The next item would be the cover. So the battery cover is permanently sealed to the top of the case. The cover has openings for the terminal posts and vent holes for the venting of gases. Some batteries have terminals extending through the side of the case, and other batteries have terminals in the sides and top. Serviceable batteries have removable vent caps that may be removed to add water or test the electrolyte. These vent caps may be individual, strip type, or box type. Another one is the battery plates. Battery plates contain a grid or coarse screen. In some batteries, the plate grids are made from lead mixed with antimony, which stiffens the lead. Battery plates are a coarse grid on which the active plain material is pasted. Many batteries manufactured today have plate grids made from lead and calcium. In some plate grids, the horizontal and vertical grids are positioned at right angles to each other. Other plates, or rather other plate grids, have vertical support bars mounted at an angle to the other vertical grids. The active plate materials are pasted on the grids. The material on the positive grids is lead peroxide, and the negative plate material is sponged lead. A tab on the top of each plate grids allows the plate to be connected to the cell connector. A cell group contains a number of alternately spaced negative and positive plates. A negative plate is positioned on the outside of its cell group. Each cell group has an odd number of plates. For example, a cell group may have 5 positive plates and 6 negative plates. Thin, porous separators are positioned between the negative and positive plates. Separators are positioned between each pair of battery plates to keep the plates from touching each other. Separators are made from fiberglass sheets or plastic envelopes that fit between or over the plates. The separators prevent the plates from touching each other and shorting together electrically. Cell connectors are lead burned to the positive and negative plate tabs in each cell group. These cell connectors also extend through the partitions. The partition between the cell and the negative plates and are connected to the positive plates in the next cell. The negative plates in one cell and the positive plates in the opposite end cell are connected to terminal posts that extend through the top or sides of the battery. So on top terminal batteries, large round terminal posts extend through the top of the battery. The positive post is larger than the negative post. These terminal posts are sealed into the battery cover to prevent electrolyte leakage around the post. Positive or negative is stamped on the battery cover beside the proper terminal post. The battery cable ends are clamped to the terminal post. On side terminal batteries, the battery terminals are threaded and the cables are bolted to the terminals. Battery electrolyte. The electrolyte is a mixture of approximately 64% water. That is distilled water. And plus 36% sulfuric acid or H2SO4. The electrolyte reacts with the plate materials to produce voltage. The electrolyte must contain enough sulfuric acid so it does not freeze in extremely cold temperatures. If the battery contains a higher percentage of sulfuric acid, this acid would attach and deteriorate the plate grades too quickly. Sulfuric acid is a very strong corrosive liquid. It is damaging to human eyes and skin. Always wear face and eye protection and protective gloves and clothing when handling batteries or electrolyte. If electrolyte contacts your skin or eyes, immediately flush with clean water and obtain medical attention. Actually, you don't have to mix the distilled water and the sulfuric acid to make a battery electrolyte. You can also purchase already a ready battery electrolyte that can be readily poured into the battery, and it's already having the specific gravity of 1.32. So battery electrolyte is also called battery solution. So battery electrolyte is very damaging to vehicle paint surfaces, upholstery, and clothing. Never allow electrolyte to contact any of these items. So let's now talk about the battery operation. If one negative plate and one positive plate are placed in an electrolyte solution, a chemical reaction takes place that causes about 2.1 volts difference between the plates. Because a 12-volt battery contains 6 cells, the total voltage of a fully charged battery is 12.6. Sometimes it goes as high as 13 volts. If an electrical load, such as a light valve, is connected to the two battery plates, the higher voltage on one plate forces current through the bulb to the opposite plates with the lower voltage at a controlled rate. This action is called battery discharging. A battery cell with two plates will not supply much current flow, and so plates are connected in parallel within cell case to increase total current capability. If a voltage source, such as an alternator, is connected to the battery plates, the alternator forces current flow into one plate and out of the other battery plate. This action is called battery charging. The voltage of the alternator must be higher than the battery voltage to allow the alternator to force current through the battery. In a fully charged battery, the positive plate material is lead peroxide or PbO2, and the negative plate material is lead or Pb. When an electrical load is connected across the battery terminals, the voltage difference between the plate material forces current through the electrical load. As the battery discharges, the H2SO4 breaks up the electrolyte and the sulfate SO4 goes to both plates where it joins with the Pb to form lead sulfate or PbSO4 on both plates. The O2 on the positive plates joins with the hydrogen H in the electrolyte to form H2O. As the battery discharges, the percentage of water increases in the electrolyte unit until it is fully discharged. In a fully discharged battery, both sets of plates are coated with PbSO4, and the electrolyte is mostly of H2O with very little acid. With a charging source, such as the alternator or the DC generator or a battery charger, is charging the battery, the SO4 comes off the plates and joins with the H in the electrolyte to form H2SO4. The H2O breaks up and the O goes to the positive plates where it joins with the Pb to form lead peroxide or PbO2. When a battery is charging, hydrogen gas escapes at the negative plates and oxygen gas is given off at the positive plates. When combined, these two gases form H2O. Because of the possibility that not all the hydrogen gas will have recombined with the oxygen to form water, caution should be taken to prevent sparks near a charging battery. The SO4 is always on the plates or in the electrolyte. Because H2O is the only liquid gas from a battery, this is the only liquid that should be added to a battery. Do not let a battery overheat during charging. The plates will become damaged and shorten the battery's useful life. If the battery case is becoming hot, turn off the charger and let it cool down. Then continue charging at a lower rate. Low maintenance batteries are designed to minimize heat and water loss. The filler caps may be removed to add water to the cells. In many batteries, the electrolyte should be at a split ring around the indicator below the filler cap in each cell. The water level must be above the battery plates. The average interval for adding water to a battery is approximately 15,000 miles. If the battery requires frequent addition of water, the charging system voltage may be too high. Newer models of vehicles are having now free maintenance-free batteries. Maintenance-free batteries are designed to reduce internal heat and water loss. The cells in these batteries are vented, but the filler caps cannot be removed, and it is not possible to add water to the battery. Most maintenance-free batteries have a built-in hydrometer in the top of the battery to indicate battery state of charge. If this hydrometer indicates a green dot, the battery is sufficiently charged for test purposes. When the hydrometer appears dark, the battery charge is below 65%, and a clear hydrometer indicates a low electrolyte level. Now let's talk about the battery ratings. The cold cranking ampere or CCA rating indicates the amperes the battery will deliver at 0 degrees Fahrenheit or at negative 18 degrees Celsius for 30 seconds while maintaining a voltage above 1.2 volts per cell or 7.2 volts for the complete battery. The CCA rating for most automotive batteries is between 350 and 800 amperes. CCA is the most common battery rating used. The other one is the reserve capacity rating. The reserve capacity rating is the length of time in minutes that a fully charged battery at 80 degrees Fahrenheit or 27 degrees centigrade will deliver 25 amperes with the voltage remaining above 1.75 volts per cell or 10.5 volts for the complete battery. Many reserve capacity ratings are between 55 and 125 minutes. Now let's talk about the connection of two batteries. And this one is a parallel connection. Two 12 volts is connected together and it makes, this is a 12 volts each battery at 200 ampere hour bank. The two positive are connected together by a cable and two negative terminals are also connected by a cable. It is always the best practice to use a red color uh, cable to connect the positive post, and black color of cable is going to be used to connect two negative posts. The negative post of the battery, the inmost negative post will be used as a chassis ground. So the cable will be connected to the chassis in order for the vehicle to have a chassis ground. And we know already that chassis ground is a continuity of current. The current will not flow battery from positive to negative if the chassis ground is not, or rather the cable is not connected to the chassis and make it as a chassis ground. So in parallel connections, very easy to remember that positive is connected to positive and one negative, the first battery will be connected to the second negative of the next battery. And the positive is red color and the negative post is black color. And the positive end of the battery will be connected to the positive load, which goes to the starting motor and many other components of the vehicles. So when you are going to have a parallel connection, connecting two batteries, positive, positive, negative, negative, the ampere hours will increase, but the voltage will stay the same. Okay, it will remain as 12 volts output of the battery. Series connection is different. The purpose of the series connection of two batteries connected together is to make a 12 volts to become a 24 volts output of the battery. So two batteries are connected together. Negative is connected to positive cable. Two posts for two batteries, positive and negative connected together. The other end of the battery with negative post, the cable will be connected to the chassis as ground. Okay, as we know already that the ground is a continuity of the current flow. and the other side of the battery is positive, will be connected by a cable to a positive load like starter motors, uh, lights like headlights, taillights, and many other things. So the series connection is negative to positive cable from one battery to another. Okay, the negative post is for chassis ground, and the other positive load is for the components that needs electricity. So when it comes to series connection, 12 volts will become 24 volts as an output, and the voltage will increase from 12 volts to 24 volts. And this kind of voltage is being utilized by heavy duty trucks, which has a 24 volts of starting motor and output of alternator, and 12 volts for all the bulbs of various lights of the vehicles. So the voltage increases from 12 volts to 24 volts, and the ampere hour stays the same. Now I'm going to talk about how to identify positive and negative terminals. You could not go wrong with inter, with interchanging the positive and negative, because it has different sizes. The post of the positive pole or the positive post is bigger in size in terms of diameter compared with the negative pole of negative post. Okay, so the cable, which is the black, will not fit from negative to positive, or the positive cable, which is will not fit to the negative post interchangeably. So you cannot interchange both cables from negative to positive, and the other one from positive to negative. Aside from that, the color of the plate that you're going to insert, or the ring that you're going to insert as an identification color for the positive post, you're gonna use the red color, but for negative post, you're gonna use either black or green color, which makes it a negative. And the negative, we know already that negative cable will be connected to the chassis as ground chassis, rather as chassis ground. Aside from that, aside from the diameter size, we know already that the positive is bigger than the negative post. There is also a markings on the close to the post. Like for example, if it's negative, this is a negative post, then there will be a marking of negative sign or a minus sign. And the minus sign will also be stamped on the connector or the cable connector. If you are using a smaller ampere hour battery, usually the positive and negative posts are smaller compared to bigger battery. So a sleeve adapter is going to be installed in order for your bigger cable adapter will fit into the positive post and the negative post. Okay. So that's it for today's topics, and I'd like to thank you for watching this video. Thank you.